Hi guys, so today we're going to be talking about Chapter 5, Section 6, using multiplicative inverse to solve equations. So we're going to go over the content for today, and then I will be making an announcement later on afterwards. So let's start off with review first. So I'll give you a few minutes to answer this problem. It's asking you to divide the following fraction and find out the quotient. So I'll give you a few minutes to do that on your own. Alright, so right here, we're being asked to divide the fractions 5 over 6 divided by 10 over 12. Now, if I'm going to divide, I need to first change my division sign into a multiplication sign. And then the other thing is I need to flip the fraction where the 12 is going to go on top instead and the 10 is going to go on the bottom. And then for the 5 over 6, I just leave it be. Okay, so from here, what I need to do is I need to simplify the 6 and the 12 first. If I'm simplifying 6 and 12, I need to divide both numbers by 6 first. So 6 divided by 6 and 12 divided by 6. That would equal to 1, and this would equal to 2. I can also simplify here the 5 over 10. So right here, I could divide both numbers by 5. That would equal to 1. And then 10 divided by 5 equals to 2. So my new numbers are going to be 1 over 1 times 2 over 2. Cool. So right here, if I multiply 1 times 2 over 1 times 2, I get 2 over 2, which also equals to just the number 1. And so that would be my answer. Okay. Alright, so for today's new lesson, we're looking at solving a one-step equation. So right here, it's asking us to solve the equation 4 over 7x equaling to negative 12. So we know that for solving an equation, we need to do the opposite. So since 4 over 7 is multiplying with x, right? We know that for solving equations, we need to do the opposite operation. So in this case, we need to divide, right? So what I'm going to do here is I am going to divide 4 over 7 on both sides. Now if I divide 4 over 7 on both sides, it will turn 4 over 7 divided by 4 over 7 into a 1. So in a sense, it cancels out the left side. Now the only side I really have to worry about is the negative 12 divided by 4 over 7. So over here, I'm just going to rewrite it. We have here negative 12 dividing by 4 over 7. And on the other side, we have the x. I'm going to change the negative 12 into a fraction. Since a whole number, we get negative 12 over 1, dividing by 4 over 7. That equals to x. Now, what we need to do is, again, if we're dividing fractions, change the division sign into a multiplication sign. And then also flip the 4 over 7. So I get here 7 over 4. And the negative 12 over 1 just stays the same. That equals to x. So I'm going to check it out. I think the only thing I can simplify here is the 12 and the 4. I can divide both of them by the number 4. If I do that, that equals to negative 3. This side equals to 1. So I'm left with, and I'm going to write it over here on the right side, x equaling to negative 3 over 1 times 7 over 1. And so in the end, my answer is going to be negative 3 times 7, and then 1 times 1, which just equals to negative 21 over 1. And so x is going to equal to negative 21. Okay? And so if we want to check our solution, we can always plug this negative 21 back into our x value here. So if we have 4 over 7, and remember, this is just checking our answer. If we have 4 over 7 and we're multiplying negative 21, we should get the answer negative 12. So if I change this into a fraction, the whole number negative 21 will turn into negative 21 over 1. That equals to negative 12. And then over here, I can simplify the negative 21 and the 7 by dividing both by 7. If I divide both by 7, I get 1 and negative 3. So I would get my new fraction, which is 4 over 1 times negative 3 over 1, which would also equal to negative 12, right? Because we have negative 12 over 1, and that just equals to negative 12, equaling to negative 12. So we know that for sure negative 21 is our answer because our check statement was correct. Cool. So this is our answer. All right, let me clear it. And let's go to two-step equations. So this one is actually not a one-step equation. We have here a two-step. Now when we're solving this two-step equation, we see here that we have negative 11 over 15 times x plus 4 over 5 equaling to 1 over 3. Now, I like to always deal with adding and subtracting first. It just makes it a little bit easier to do. So right here, I have 4 over 5. I want to cancel it out by subtracting it by 4 over 5 on both sides of the equation. So if I do that, that cancels out that positive 4 over 5, and I'm left with negative 11 over 15 x equaling to 1 over 3 minus 4 over 5. So let's combine this part first. Over here, I see that we have two different denominators. So the first thing I need to do is make it so that they're the same denominator. I know that 15 would work for both of them. So right here, if I multiply 5 to both numbers, and I multiply 3 to both numbers, I get 5 over 15 minus 12 over 15. And on the other side, I still have 11 over 15 times x. So from this, I get 11 over 15 times x equaling to, let's see, that turns into 5 minus 12 over 15. And then we get here, I'm going to go and write the rest on the left side here. So 11 over 15x. 5 minus 12 equals to negative 7 over 15. And then after I do that, I see that the negative 11 over 15 is multiplying with x. So again, I'm going to divide negative 11 over 15 to both sides. That would cancel out that fraction. And so I would be left with x equaling to negative 7 over 15 dividing by negative 11 over 15. So again, I'm going to change my division sign into a multiplication sign. And then I'm flipping my fraction around. So now when I get my new equation, I should get x is equal to negative 7 over 15 and negative 15 over 11. So after I do that, I can start simplifying. I can simplify the 15 and the 15 by dividing both of them by 15. If I divide both of them by 15, I get 1 and 1. So I'm left with x equaling to negative 7 over 1 times negative 1 over 11. And so that would equal to positive, because we have here negative 7 times negative 1 over 1 times 11, positive 7 over 11 as our answer. Cool. So let's try out the problems ourselves. Let me clear the slide. And let's try out this problem over here. So the question is asking you to solve for the following. We have here 16 equaling to 3 over 4n minus 4. So I'll give you a few minutes to try out this problem on your own. Alright, so again, I want to start off with using any addition or subtraction. So right here, if I have negative 4, I want to cancel it out by adding 4 to both sides. If I add 4 to both sides, that cancels out the negative 4, and I'm left with 16 plus 4. 16 plus 4, that equals to 20. And then we have here 3 over 4 times n. Now, since we're multiplying by n, the opposite operation would be to divide by 3 over 4 on both sides. So if I divide by 3 over 4 on both sides, that cancels out that 3 over 4, and you're left with 20 dividing by 3 over 4. So right here, I'm going to write down 20 dividing by 3 over 4. And that equals to n. So right here, I'm going to make sure that I change my division sign into a multiplication sign. And then I'm also going to flip the 3 over 4 to 4 over 3 instead. And so right here, I'm going to change it so that I have a fraction on both numbers. 20 as a fraction is just 20 over 1. And then I still have n here. So I'm left with 20 times 4, 1 times 3, equaling to n, which would be 80 divided by 3, equaling to n. And that would be my fraction. Okay. So hopefully this helps. Good luck.